Hello, yes, and welcome back. This video we are going to go over the quiz F.1-2, which is the quiz over units 1 and 2 before our final. It aligns with problems numbers 1 through 12 on the review I posted on Teams. Ideally, I want you to go through this video after you've already tried this quiz on your own to check your work. So with that being said, if you haven't completed the quiz, go ahead and pause the video, do that first. If you have, then let's get started. So number one asks us to identify the center and radius of a circle and sketch a graph of the circle. So for this one, we need to remember that, oh goodness. Let's see if I can't get this to work. Why is this not working? Alright, there we go. Sorry about that. So we need to remember that our circle is the equation x minus h squared plus y minus k squared equals r squared, and that's where hk is the center and r is the radius. So with that being said, we can look here. So our h value would be -4. Remember, it's the opposite since it's subtraction in here. And the k value would be 3. So our center is at the corner point -4, 3, which is right here. To find our radius, we just take the square root of 25, which is 5. And then to draw, we need to go 5 units away from this guy. So 3 would go to 8, 4 would go to 1, 3 would go to -2, -4 would go to -9. And then just do our best here to create a circle about as best as we can. That's not terrible. All right, and there you go. That's number one. All right, looking at number two. Write the function represented by the graph. So this is a quadratic, so we can use vertex form. So remember, vertex form is y equals a times the quantity x minus h squared plus k. H and k is my vertex. So that means y equals a times the quantity x minus h is the x value, so 3 squared plus k is the y value, which would be 2. Very good. And now, all that we need to find is a, and then we will have our equation. To find a, we can plug in 4, 0 for x and y. So it'll be 0 equals a times 4 minus 3 squared plus 2, and then we can solve that for a. Subtract 2 equals a times 1 squared. Well, that would just be 1, so a equals -2. So my function would be f of x equals -2 times x minus 3 squared plus 2. And there we go. If you put y, I'm sure that's fine. They did specifically ask for a function, so when that's the case, I would recommend writing it in function notation, just to show that. Alright, find all solutions to the following inequalities. So we have an absolute value inequality. First thing is I got to isolate the absolute value, so I'm going to divide by 2. When I do that, I get the absolute value of 3x minus 8 is less than 5. So what does that mean? Remember, we're going to split it now to two inequalities. 3x minus 8 is less than 5. Or 3x minus 8, flip the sign and flip the value. Very good. So I add 8 here, so 3x will be less than 13, which means that x is less than 13 thirds. Or add 8 here, 3x is greater than 3, divide by 3, which means x is greater than 1. So we have these solutions here. Write it in interval notation. So this would be 1 to 13 thirds. Soft brackets since it's strictly less than and greater than. Excellent. And that's number 3. Looking at 4 and 5 now. So looking at number 4, we're going to use f over g of -1. So remember, this is the same thing as f of -1 divided by g of -1. So I'm going to find f of -1 first. 2 times -1 would be -2 plus 4 is 2. G of -1, let's write this out. So I'll have -1 squared plus 4 times -1 minus 3. So that'd be 1 minus 4 minus 3. 1 minus 4 is negative 3. Negative 3 minus 3 is negative 6. So 2 over negative 6. So we would find, that will of course reduce, we'd say that f over g of negative 1 equals negative 1/3. There we go. And that's number 4. Looking at number 5. F of g of x. So for this one, we need to put g of x inside f of x. So to do that, I would say 2 times, and now g of x squared plus 4x minus 3, and then plus 4. Don't forget the plus 4 from f of x. So that'll give me 2x squared plus 8x minus 6 plus 4. Negative 6 plus 4 can be simplified. We define that f of g of x equals 2x squared plus 8x minus 2. And I'm done. I do not need to simplify that. I do not need to solve it. I do not need to factor it. I'm done right there, okay? And that's 4 and 5. Hopefully we're doing good so far. Let's look at number 6. Given this function, find its inverse. So remember, first step to finding an inverse is replace f of x with y. So negative 3/5 x plus 2. And then switch x and y. So x will equal negative 3/5 y plus 2. And now my new goal is to solve for y. So I'm going to start by subtracting 2. X minus 2 equals negative 3/5 y. And then I need to multiply everything by 5. When I do that, I would get negative 3y equals 5x minus 10. And then divide everything here by negative 3. Divide by negative 3. So I would get y equals negative 5/3 x plus 10/3. And my final answer, remember, we want to write it as the inverse. So I'll say f inverse of x equals, and we have negative 5/3 x plus 10/3. Beautiful. Fantastic. Okay. Looking at number 7, the graph of a piecewise function. This is something we struggled with. So remember, this one needs to still be a function, so it needs to pass the vertical line test when I'm all done with this. So I'm going to start by looking at our domain restrictions here, and I'm going to create some dashed vertical lines at these values. So one's at negative 3, create a dashed vertical line here, and then one is at 2, create a dashed line here. Fantastic. Okay, so first one, I see if x is less than negative 3, the value is just negative 3. So I'm going to go ahead and create an open circle on negative 3 and run it out to the left there. Beautiful. That one's done. Negative x squared plus 5. All right, negative x squared plus 5. 5 is here, and then I need to know that pattern. So we're down 3. So we'll have an open circle there. 1, 2, 3, 4, 5. There we go. Closed circle there. Then we can go ahead and connect these dots. That parabola graphed. Beautiful. And now 2x minus 1 if x is greater than or equal to 2. So remember, this minus 1 is from the y-intercept, so it would be here on this coordinate plane. And then I'm going to go up 2 over 1, up 2 over 1, close circle since it's greater than or equal to 2. And then I can continue from there, up 2 over 1, up 2 over 1, up 2 over 1, and draw my line to connect those dots like so. Beautiful. All right, that is number 7. All right, notice how it still passes the vertical line test. We're looking good there. All right, number 8, determine if the graph below represents an even, odd, or neither function. Explain. Okay, so let's review it. Even function is symmetric to the y-axis. An odd function is symmetric to an origin, and a neither is neither of the y-axis or origin. So, looking at this graph, we first ask, is it symmetric to the y-axis, which would be this guy here? Well, obviously not, and we'd have to have a graph over here to mirror this one and a graph down here to mirror that one, so definitely not an even function. Is it an odd function? So that means if I take that origin and I rotate this 180 degrees around the origin, would I get the same thing? And the answer to that is no. So this is neither. And for the explain, you can say it's not symmetric to the y-axis or the origin. And there we go. Very nice. All right, number 9 now. Last one, I believe. Given the graph of f of x, sketch the graph of negative f of x minus 2. So, okay, couple things to remember here. The negative tells me to flip over x. And then the minus 2 tells me to move everything right 2. Okay, so first thing I'm going to do is flip over the x-axis. So if I flip this point, well, that wouldn't move at all. This is at positive 3, so it will now move to negative 3. Positive 1 will go up to, or negative 1 will go up to positive 1, and then again, positive 3 goes down to negative 3. So there's those points. And now I'm not going to draw the shape yet because now I need to move all of these points right 2. So this one that was originally at negative 4, 0 is now at 2, 0. If I move this one right 2, it'll be here. Move this one right 2, it'll take it to here. And move this one right 2, it'll take it to here. And now I can try to draw these lines. So I have a straight line from here to here, straight line here to here. And notice this last line is curved, like a parabola almost. So it'll be going like that. There we go. And that's it. That is a review of Units 1 and 2. Hopefully we were feeling pretty confident. Feel free to use this on when you take the final exam. Have this nearby so you can reference it as well. Again, the final is open note, so use your resources, okay? This is Mr. Carter signing off. I will see you next time.